Okay, so today we are going to discuss some cases of pulley. Okay, that is very simple if you understand it. So here you can see it is at wood machine. Okay, this is a pulley system. Just look at here.
Yeah.
Okay, it's a pulley system, and two bodies are there. One is M1 and another one is M2. Okay, and let us
Okay.
say they are freely connected together. That pulley can move any in any direction. So if M1 is more, then pulley will move towards M1, isn't it? That
Yeah.
M1 will go down and M2 will go up.
Up.
If M2 is more, then this will be in the direction of M2.
Ink.
Okay, M2 will go down. So that is very basic system. So we'll
Yeah.
discuss three cases of the connected bodies. So first of all, this one, this is M1 mass, it is M2 mass. So because M1 is greater than M2, M1 is greater than M2, so that system will be in motion.
Yeah.
Okay, and M2 will go down. So how many forces will be there? We are going to discuss it. Okay,
Yeah.
so
Okay.
as per Newton's second law, if some body is in motion, then what happens? MA
If
is
somebody.
produced. MA is
Yeah.
produced. Acceleration is produced.
Used. Yeah.
Okay. So tension will be there in this due to that M1 mass to that
Yeah.
string, that will be upward.
Yeah.
In that M2 mass, tension will be upward in this system. Okay.
Yeah. But sir, why is tension upward in both of them?
Because that is connected from there. That is just in the contact of pulley. That string is in the contact of pulley.
But one of them is moving down and one is moving up.
Yeah, but always if some string is attached somewhere, so the
Yeah.
tension will be upward to the point.
Okay. Towards the point of the pulley.
Yeah. Okay.
Okay.
Always it is there towards the contact of the pulley, isn't it? Okay. So we are going to discuss forces, whatever is applied on this system. So first of all, we'll see that M1 mass is going downward,
Yeah.
isn't it? So how many
Yes.
forces are there on the M1 mass?
One, two.
The weight is downward,
Yeah.
the tension is upward,
Upward. Yeah.
and another force, that is MA, that is resulting it for its motion.
1 second. How the three? I didn't understand the third force.
Third force will be produced because of unbalancing of these two forces. That's why it will
The
be,
resultant, right?
yeah, it will be a
But the
resultant.
resultant is not another force, right? It's just a combined effect of the two forces, right?
Yes, you are right.
So how is that a different force?
You are right. Because it is not a different force. These
But
are
you just said there are three
inside,
forces acting.
yeah, the three forces acting, and you have to determine which force is acting in which direction. Okay. So
Okay.
that is a simple rule. So just add two forces which are in the same direction and just subtract the result, the opposite direction force, and the sum of all these forces will be 0 if it is in equilibrium, but this is not in equilibrium.
Yeah.
It is in motion. So
Yeah.
that unbalancing of two forces will result it in motion. Okay.
Okay.
And that motion is produced, that motion will be given by MA. Okay.
Okay. So that is another force you have to consider.
Yeah. So unbalancing of these two forces will produce another force, that will be a force of motion.
Okay.
Okay. So for this M1 mass, so mg is more,
Yeah.
isn't it? Mg is more than tension, that's why it is going down. Okay.
Yes.
So for M1 mass, it's just a moment. For M1 mass, M1G minus T will be equal to M1A, isn't it?
Okay.
Because M1G is more than tension.
Yeah.
So the resultant of these two will give you another force, that is a force of motion, that is M1A. Got it?
But what's the difference between M1G and M1A?
M1G is a different force because the force that will be its weight. If you
But
see, if you see,
isn't AG in this
if you
case?
see this mass, that will be mg downward,
Yeah.
T will be upward,
Yeah.
but it is not an equilibrium. If it is an equilibrium, then T will be equal to mg.
Yeah.
Okay. So this is in motion. So resultant of these two forces will be giving you the force of motion, that is ma. Okay.
Okay.
So that mg minus T, because mg is more than T, so
Okay.
that's why we are just subtracting mg minus T, so that will be equal to ma. Got it?
So, but yeah, but why is it always written M1 M1G? Look at over there, which are
Yeah, because this is m1 mass. So this is m1 mass. So we are just writing m1g minus T equal to m1
no,
A.
no, not over there. In the box which I've circled, look on the side of it. There's another M1.
This is m1
No,
mass.
no. Look on the left side of it. Look on the left side of the book. There's another M1. Now for mass M1, M1G minus T.
Yeah,
Okay, okay, okay.
it is
Understood.
just m1 comma. It is just m1 comma.
Okay, okay, okay.
Okay.
So I thought it was like multiplication.
No,
That's
no, it is not multiplication. It will be m1g minus T equal to m1a. Got it?
okay. Yeah,
Okay. And what about the second one? That is m2. So now m2 is going up.
yeah,
So how many forces are acting on this? The m2g will be downward
yes,
and T will be upward, and this m2 mass is going up. So that's why your T will be greater than m2g, isn't it?
yeah,
So in that scenario, in mass of m2 mass, so the T will be more, T minus m2g will be equal to m2a, and because m1 and m2 both are connected, so the same acceleration will be produced in it. It is working like a single body. Okay.
okay.
So single body will always have the same acceleration. So that will be the equation for m2 mass. Do you understand these two equations? How I got it? Okay.
Yes,
Now with the help of these two equations, we are going to find its tension as well as its acceleration. Can we find it? We have two
yes,
equations, two unknown things, that is acceleration and tension. So by solving these two equations, we can find out the acceleration and tension. Isn't it?
yeah,
Okay. Can you please solve these two equations? One is T minus mg2 equal to m2a. Another one is m1g minus T equal to m1a. If you add these two equations, what will happen? T will be cancelled.
yeah,
So adding 1 and 2, so 1 plus 2, what it makes? T will be cancelled and it becomes m1g minus m2g equal to m1 a. I can take it common, so it becomes m1 plus m2 into a. So what a will be? A will be equal to m1 minus m2 into g. So your a will be equal to m1 minus m2 into g divided by m1 plus m2. And you always need not to mug up this formula, okay? Because if you know the logic, then you can find out the acceleration like this, isn't it?
yes,
But if you have lesser time, then you have to remember this formula. Okay, so by that formula you can do it in some seconds, isn't it?
Yes.
Okay, do you understand this part?
Yeah.
Okay, and what will happen if you put value of a there in the second equation? So then you can have t. Okay, so after solving these equations you will get it that t is equal to 2 m1 m2 divided by m1 plus m2 into g. Is that understood to you?
Yes.
Okay, and another force is acting upon the suspension of pulley, that is your reaction force. Okay,
Yeah.
and reaction force will be balancing these two tensions. Okay, we are just focusing about this reaction force which is applied on this pulley. So this reaction force will be equal to 2t.
Okay.
Okay, do you understand it? So it will be equal to 2t. So the reaction force will be equal to 4 m1 m2 g by m1 plus m2. Do you understand this part?
Okay. Just basically first need to but solve for t, right? Then you can do this.
Yes.
Okay.
Okay.
But what is reaction exactly? Can you tell again?
Which one? Which one?
What is reaction?
Reaction force is to balance these two tension force. Another force is acting on this point, the balance point.
Okay.
Okay.
To balance the two forces.
Yeah. So that will be equal to the addition of these two forces, because if you are hanging some buckets filled with water in your hand, both of the hands, so some force is applied on the first hand, some force is applied on the second hand. Okay.
Yeah.
So there is a reaction force also. So you are just applying reaction force that will balance this weight. Okay.
Okay. But if it's balancing the weights, then like how will the objects move the two masses?
Yeah, they are just moving because of the freeness of the pulley. Because
But you
that,
just said that it is balancing the forces, right?
yeah, this point is balancing the forces. These two tensions, it is balancing for these two tensions only.
Okay, so the two tensions are equal.
Yeah, so reaction force will be like upward. Okay, reaction
Okay.
force. Reaction force is always once two bodies are in contact that there will be a reaction force. Okay,
Okay.
got it? Okay. So if you want to note it down, just note it down.
If in this case there were like three masses, then like the tension would be 3t, right? I mean the reaction would be 3t, right?
If how it can be 3t?
No, if there was another mass.
So tension will be one only. If you are hanging another mass with this m2 mass, then scenario will be different. Okay.
Okay. Okay, yeah.
You just note it down it. Then we'll do some questions on based upon this. Then you will understand it. Now we'll have another scenario. So the case 2 is this is your pulley, and this pulley is fixed upon the table. Okay, and this mass m1 is moving as your mass m2 is hanging there. Okay, so what kind of forces you will have? The tension in the string will be like this. Okay, got it?
Yes.
In this scenario,
But sir, this is like if friction isn't there, right? Or else
yeah,
it will
yeah,
change.
yeah, friction is not there.
But if friction isn't there, won't the blocks just slide off?
Yeah, it will also slide, but the resultant force will be subtracted by the friction. Okay.
Okay, so it'll basically stay the same. You just minus friction from it.
Yeah, you are right. Okay, we'll
Okay.
talk about that once we finish that friction.
Okay. Okay.
Okay.
Yeah.
So in this scenario, your mass m2 is having weight mg and the normal force. So these two vertical forces will be balancing each other. Okay.
Yes.
So in this scenario, mg will not be into the picture, isn't it?
Yeah.
Okay. So how many forces are there? Only tension and the force due to
Tension.
acceleration. If it is sliding down,
Yeah.
okay. So for the mass m1, only T will be equal to ma, tension and force due to the motion. Okay.
So, I didn't understand. So, okay, both the tensions are actually opposite action because they're both pointing towards the pulley, right? Because
Yeah,
one
one
is,
one tension is because of this m2 mass.
yeah, it's pointing towards pulley, and the other is also pointing towards pulley. That's why they're in opposite direction.
Yeah. Always tension will be towards the fixed point,
Friction point.
where it
Okay.
is, where the string is fixed. So this string is like, we can say that it is also rolling, but we can say that it is just attached to this pulley, so that tension will be towards the pulley. Okay.
Okay.
So actually this notation must not be here, this must be here. Okay.
Okay.
So this is tension caused by m2 mass and this is tension caused by m1 mass. And
Yes.
this weight and normal force will be cancelling each other as they are in opposite direction. Okay. So only two forces are applied on this m1, the tension force and the force by the acceleration. Okay.
Yeah.
So the tension will produce force by acceleration, so that T is equal to m1a. Do you understand it?
Yes.
Okay. For the second one, that m2g is downward, tension is upward. Okay.
Yeah.
The body is also moving. So the resultant of T and mg will be giving you m2a, isn't it?
Okay.
So in this scenario, the body m2 is going up. That means, sorry, the body m2 is going down.
Yeah.
Okay. So if m2 is going down, so that means m2g will be more than tension.
Yeah.
So you have to subtract tension from m2g and that will produce your force due to acceleration.
Yeah.
Got it, this one?
Can the block ever move upwards?
No, how it can move upward here?
Yeah, exactly. It can never move upward, right, in any situation.
Yes. Because this block cannot move like this
Yeah.
because it is a flatter surface.
At max, it can just stay at a constant location if it's
Yes.
equal.
So at that point of time, all forces will be in equilibrium, there will be no motion, acceleration will be zero.
So, mass into acceleration of both of them will be same.
Yes. Okay.
Okay.
Got my point? So m2g minus t equal to m2a. Now just put your t into this equation, you will get your acceleration. Okay.
Yeah.
So we'll put m2g minus t as m1a equal to m2a. Now take your m1a that side. So it becomes m2g equal to m1 plus m2 into a. So your a will be m2g divided by m1 plus m2. Do you understand it?
Yes.
Don't mug it up, just see that, just learn the concept. Okay.
Yeah.
Earlier, once both of the masses were moving freely, that time it was m1 minus m2g,
Yeah, but now M1, but now M1G is getting balanced out by contact force, right?
normal force.
Normal force, yeah.
So that's why M1G is not in the picture. Okay.
What's the difference between normal and contact?
Contact force is just contact force is a broader category. Okay.
Okay.
Normal force is one kind of contact force.
Because there can be many types of contact
Yeah,
force,
yeah, yeah.
not just one.
Already we discussed in the previous class. Okay. Friction is also a contact force. Normal is also a contact force. Okay.
No, are there any other, like except normal and friction?
Normal and friction, I think only two types are there only.
Okay.
Okay. Reaction is also there, and reaction is also like one kind of normal force as it is. Okay.
Okay.
So do you understand how to find A? Now you just put A value into the first equation, you will get it T. So T will be M1 M2 G by M1 plus M2. Okay.
Yeah.
Okay, and you can see in the uh, previous concept where both the masses were free to move, there was 2 M1 M2 G.
Yeah.
Okay, but here
Yeah.
only M1 M2 G by M1 plus M2. Got it?
Yes.
Okay,
No, sir, I was writing it.
you're writing.
Yeah.
How it can be written? Yeah, you can note it down from this one. Okay, do you see it?
Yes.
Okay, we note it down from this. We'll do some questions based upon this, then you will understand all. Okay, sometimes two bodies will be in the contact and both of the bodies will be moving together. Okay, so that time if two bodies are in contact, then the these combinedly can we say it as a single body. Okay,
Okay.
it can be considered as a single body. So if M1 and M2 are in contact, then the entirely we can say it as it is a single body is M1 plus M2. Okay.
Yeah.
So if it is in motion, then F will be M1 plus M2 into A.
Yeah.
Okay. Got it?
Yes.
Okay.
Yeah.
Now, if the force exerted by M2 on M1 is F1, let us say M1 is also applying some force on M2 is also applying some force on M1.
Yeah.
Okay. So let us say this force is F1, force of contact, then the body M1, the force of contact of the body M1. How much force is being applied? The resultant force of these two forces, capital F force is applied by the M1 body to M2.
Yes.
Okay, just we will figure it out here. Yeah. If we talk about M2 body here, this one, let us say it is M2. So that capital F force is applied by small m1. Okay.
Yeah.
So that force direction will be like this, and on M1, this M2 body is applying force F1. Okay.
Yeah.
So how much will be the resultant force? Resultant force will be F minus F1. Okay.
Yeah.
So that will be F minus F1 equal to M1A.
Yeah.
M1 will be in motion, but the resultant force will be F minus F1. Isn't it? Okay.
Yes.
Okay. And by M2, how much force it will apply? The value of F1 will be given by M2A. this much force M2 will apply. Okay.
Yeah.
So now by combining these two equations, we can find out the value of F1.
Yeah.
So the value of F1 will be, if we solve these two equations, so the value of action of M1 on M2 will be given by M1 M2F divided by M1 plus M2. By solving these equations, we can find out this. Okay. Just
Yes.
please note it down.
Okay, sir.
Now we'll do some questions based upon this technique. Okay, just try to do this example 38. Is it visible to you?
Yeah.
Okay. Example 38. First of all, try to draw the figure. If you have drawn the figure and then just draw the forces which are applied upon this block, then you will be able to solve the question. So in the second one, normal reaction force will also be coming into the picture.
Yes.
Okay. So just draw free body diagram and just try to solve this question. Okay.
Okay. Yeah.
Just consider what force is in which direction. So the question is, a wooden block of mass 2 kg rests on a soft horizontal floor. So that is a wooden box, let us say. This is a wooden box. Its mass is 2 kg. So that weight will be how much? If G is 10,
20.
so 20 Newton will be the weight and that will be pointing downward. Okay. How much will be the reaction force? The reaction force will be equal to the weight only.
Yeah.
So once the wooden block, so that wooden block, the 20 Newton reaction force will be applied by the floor on the wooden box. Okay.
Yes.
So this will be the reaction force once the cylinder is not there on this wooden box. Okay.
Yeah.
Okay. So that is your A part. Before applying, before putting cylinder on the box, that will be its reaction force. Okay.
Yes. But you just said reaction force was tension, right? And now you're changing it. You just said this was normal.
Reaction force is not tension. Reaction force in that pulley case, it was balancing tension.
But now you're saying that I don't know. So
Re-
this is normal, right? 20 Newton, which we find out which is the normal. How is that the reaction force?
See, this is your normal force. Normal force is 20 Newton.
Yeah.
Okay. Normal force is always applied by the surface on that body. Okay.
Yeah.
So my question is, uh, the floor yields steadily and the block and the cylinder together go down with an acceleration. What is the action of the block on the floor? Okay.
Okay. Okay.
So action of the block on the floor, that
Yeah.
block will be putting 20 newtons on the floor, isn't it?
Yeah. Yeah.
So that will be 20 Newton downward.
Yeah.
So the question is only this. So block will
Basically,
block
it's an
will
action.
block will put only 20 Newton on the floor. Okay.
Okay. Since of action, isn't it better to say that the force applied by it is this basically saying we need to find the force applied by the block on the floor, right?
Yes. That is the meaning of this question, isn't it?
Okay.
Okay. Once you put a cylinder on that, so that time what happens? Once you are putting a cylinder over it, so that combinedly it becomes how much?
It becomes 270 Newton.
It becomes, you are putting 25 kg of, it is 25 kg, it is 2 kg. So the entire system is of 27 kg.
Yeah.
So how much weight will be there? That will be 270 Newton.
But sir, wouldn't there be normal between the two blocks?
This time it is behaving like a one body.
No, no, but there should be normal between the two blocks,
Yeah,
right?
normal will also be there in these two surfaces, but
But wouldn't that reduce the effect of the 25
normal
kilogram?
will be upward and weight will be downward. So that will
So won't
that
it affect the
they
thing?
will they will be balancing each other. Okay,
If it's
but
balancing each other, then why are we considering the 25 kilogram block?
if they are not balancing each other, that's why the cylinder is going downward, isn't
But you
it?
just said that they're balancing each other.
If they are balancing each other, then there will be no motion of the cylinder.
Okay.
But in this question, it is saying that as you put 25 kg on the top of the block, the floor yields steadily. Okay, they are balancing each other, but floor is not stable here.
Okay, it's balanced in such a way that the cylinder is not breaking through the wooden block.
Yeah. So the floor yields
Okay.
steadily and the block and the cylinder together go down with the acceleration. So now
Okay.
your floor, there is a, this is considered as an entire system. So entire system is of 27 kg. So that will apply 270 Newton weight on the floor. Okay.
Yeah.
But the floor is not able to sustain that 270 Newton force. That's why your floor is going downward. Okay. This entire system is just going down into the floor. Okay.
Yeah.
Got it? And the acceleration is given to you, that by what acceleration they are going, that is 0.1 meter per second square. Do you understand it?
Yes.
Okay. So now that time 270 Newton and the reaction normal force is there. This is the
Yeah.
normal force,
Yeah.
isn't it? So because your weight is more, that's why it is going down.
Yeah.
So that time W minus N will be equal to MA, isn't it?
Yeah.
So what is W? W is 270 minus your normal force will be equal to, what is M? M is 27 and A is how much? 0.1. Okay.
Okay. Yeah.
So if you find N, so N will be given by 267.3 Newton. And whatever will be the normal force, that will be the reaction of the entire system on the floor, isn't it?
No, but shouldn't mg be the? But shouldn't mg be the rea- a reaction of the entire system on the floor?
No. Mg will not be the reaction of the entire system because N is also there. Okay.
But in the previous case, you said that we'll consider mg, the below 1 mg, because
See, they were in balance.
yeah,
It is not in balance. That entire system is going down with some acceleration.
yeah,
Okay. If I am standing on the floor we are in equilibrium. I
Yeah.
am not going down. If I am going down, as you jump in the water, what happens?
You move down.
You move down. So that time your normal force is lesser.
Yeah.
Okay?
Yeah. Yeah.
So as your normal force is lesser, your weight is more, then you will go downward.
But why are we considering normal and not the mg? That's my question.
If they are in balance, then the scenario is different.
Okay.
Okay?
But like I'm not understanding why are we taking normal? Why can't we just take mg?